Hi, my name is Brock Wilcox, and for my project I learned about QuickCheck and worked on improving the usage of the Ruby implementation Rantly. First, let's talk about input-driven testing. We learned about testing logic circuits in class. Logic circuits are fun because they are a simple model of the world that we can wrap our head around. Of course, there are direct hardware testing implications, but as a software engineer, I am primarily interested in software testing. Fortunately, the stuff we learned about circuits can be translated very directly into the concepts related to unit testing software. So I'm very interested in, and QuickCheck is a prime example of, randomized input testing. So I'm going to focus on that. There's a lot of reasons that randomized inputs appeal to me. The main idea is to not use this as the only means of testing, but instead use it to supplement known cases. In class, we learned that you should get the easy tests out of the way quickly so that you can focus on the difficult cases. More recently, we saw how getting past the knee in the coverage can get you to the point where new tests are more impactful on discovering defects. Randomized input flies in the face of all the things I've learned about best practices for unit testing. The last thing I want is for my test suite to fail once every 5 executions for no apparent reason. The idea, though, is not just to generate one random input, but lots of them, and to define properties that should hold no matter what the inputs are. QuickCheck was initially written in Haskell, a pure and strongly typed functional programming language. It was shared widely through a conference paper and has continued to be popular in Haskell projects even right up till now. The concept has been ported to a variety of other programming systems, though not all of them are implemented in quite the same way. QuickCheck in Haskell is able to make use of the type system there to cut down on some of the verbosity in declaring what proper data looks like. So inspired by the initial paper and earlier works on randomized testing, there have been a bunch of published work on the concepts. Some of the current work by Hughes, for example, focuses on testing complex distributed systems written in Erlang. You can see in 2013, he has a really cool presentation where he talks about using it to detect race conditions across a lot of nodes. It's really neat. So the basic QuickCheck usage is that you declare properties, and then the system actually generates random data based on the types, and then we verify or invalidate these properties. One thing I want to point out is that the QuickCheck-like algorithms are a weak form of model checking in a lot of ways. They are only testing a limited subset of the possible inputs, but they really are verifying that the properties you've declared are fulfilled. So here we have quicksort written in Haskell. You can see that it is some fancy pattern matchy syntax, like other functional programming languages, prefers recursion-based implementations. Below that is the declaration of a property. This property says that a sorted list should be the same as the same list sorted twice. You give this function a list and it returns true or false depending on if this property of quicksort holds. Calling QuickCheck from the interactive prompt in Haskell is straightforward, though there is one detail here. By defining the types here carefully, we're implicitly telling QuickCheck how to generate the example inputs. QuickCheck will generate many lists of integers of various lengths. In this case, it defaults to generating and checking 100 of these lists. And here all of them pass the property check, so that's good. For my day job, I program in Ruby, so I decided to look into existing QuickCheck ports to Ruby. Rantly is the best one, though its implementation is very different than the Haskell QuickCheck. Haskell QuickCheck depends on the type system to help generate inputs and does so in a special monadic context, which is to say in a way that carefully controls side effects. Rantly, on the other hand, does a much more imperative generation of test inputs and can't make use of the type system because it's dynamic in Ruby and isn't nearly the same at all. It does, however, still let you build up complex structures of test inputs. Here's the Ruby implementation of quicksort and an idempotent property, very similar to what we have in the Haskell example. Here's how we actually can use Rantly. Inside of this, I'm doing RSpec framework setup, and then I'm executing it from the command line. So it's a little bit different because of the way it's wrapped in RSpec. So let's actually compare them side to side. Haskell's is much more succinct because of its type declaration cooperating with QuickCheck's input generators. Ruby's here is less concise, though part of that, like I said, is because of the way it's wrapped in an RSpec test. I've written a new RSpec integration for Rantly to improve upon this a little bit at least, and from there we get this. In this example, I've collapsed the input declaration into the subject block, which already exists in RSpec, and then I've tagged the example line after the it should be idempotent with a Rantly tag. This tells my library that instead of executing this example just once, it should execute it 100 times and generate a new subject each time. There's a few other minor things to be done leading up to using Rantly in like work production code. The Rantly library itself needs a new release. I found out that the development version on GitHub has several fixes and new features that aren't in the Ruby Gems version. Also, there's another data generating library called Factory Girl, which I've experimented with integrating the two together so that Rantly can generate Factory Girl objects. Using Factory Girl would help generate domain-specific inputs in a more useful way. So I'm very interested to see if this technique would be useful in a typical industry application, or on the other hand, if maybe property checks like this are too awkward to actually work with. So far, the jury is still out. Thank you for listening, and it has been a wonderful class.